Hello, Chemistry, Earth, and Space Science. This is the second lesson in Unit 4 about the hot and cold packs. This one, the whole unit, this whole lesson is all about different types of chemical reactions. Our goals for this series of videos is to identify different types of chemical reactions. There are 4 plus 2 major ones, and be able to predict products. That's what we want to get done in this video here. So let's start at the top. There are 4 basic types of reactions: the synthesis, the decomposition, single replacement, and double replacement. And then there's 2 specialized reactions types. That's acid-base neutralization and combustion. So we're going to go through each one of these in order. Try to notice what kinds of reactants there are and what kinds of products there are, and maybe notice some trends so we know what we can predict products. So the first type is synthesis. Well, to synthesize something means to make something. So in that same mindset, here we're going to be in a situation where we're going to be making a compound, a more complex compound, one more complex compound from 2 or more initial reactants. Normally, for what we'll be doing, we'll take elements themselves and then combine them to make a compound. It is possible to see a reaction written out in its entirety that has 2 compounds to start off with, and they combine to make one larger compound, but the key is all the reactants become one larger, more complex compound than you started with. Always going to have 2 or more reactants, and always going to have one product. So a generic example would be A plus B. A plus B giving you AB, which is like this would be H2 and oxygen making water. So both of those are ways to show a synthesis reaction. Now, when writing synthesis reactions, one thing that's going to come up a lot, and you see it in this last slide anyway, is the 7 diatomic elements, which we talked about very, very briefly in a previous lesson. 7 diatomic elements, don't forget them. Brinkelhoff is the way I remember them. Brinkelhoff, BrINClHOF, BrINClHOF, meaning bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, all only exist in nature as diatomics, ones that have a subscript of 2. All other elements on the periodic table, when found in nature by themselves, are just with a subscript of 1. The second type of reaction is called decomposition. It is essentially the reverse of a synthesis reaction. This is one where you have one product, strike that, one reactant, and that one reactant is going to break down into smaller reactants. Now, as far as we're going to do, we're going to prepare to think in terms of, if we're expected to predict a product, all of our products will be the elements that make up the compound, the more complex starting compound. So you're going to have only one reactant, and it's going to be a complex, it's going to be a compound of sorts, and you're going to have a multitude of products. So for instance, here's the electrolysis of water, where you have H2O breaking down into H and O. It starts off as water, ends up as hydrogen and oxygen. That's the electrolysis of water. The next 2 have interesting names called single replacement and double replacement. In a single replacement, look what's happening here. A element that is by itself comes in and swoops in and kicks out one of the elements that are in the compound. So for instance, this situation was the C kicked out the A and took its place. See how it's CB? That's called a cationic single replacement. You start with one element and one compound, and the element will kick out one of the substances, one of the parts of the compound, and make a new compound and kick out that new element. So this is called cationic because what you have is a metal. C would be a metal in this situation. C, being a metal, would go into the first spot of an ionic compound. So it's going to kick out the A and kick the A by itself. So here's an example. Copper, metal, If I put copper metal in a solution of silver nitrate, what will happen is the copper will come in and kick out the silver, leaving silver by itself, and we'll be left with copper nitrate. Essentially, having the copper and the silver, the two metals, switch places. The other type that's a little less common is called an anionic single replacement. And that's where you have a non-metal on the outside by itself, and the non-metal kicks out the non-metal. So you see how the C here kicks out the B and makes B by itself, and then you're left with AC. So C, this outside element, is a non-metal and take the place of the non-metal or the anion in the compound. Here's an example. Sodium chloride reacts with fluorine gas. Fluorine gas is F2. The F comes in and kicks out the Cl, leaving Cl by itself, and chlorine is one of the Brinkelhoffs. So then you get the F, the fluorine takes the place of where the chlorine was, and you get sodium fluoride as a product. And the last of the big four is a double replacement. This is kind of cool in that what happens is you have both cations just swap places. You start with two compounds, compound 1 and compound 2. These compound 1 and compound 2 are both ionic compounds, usually dissolved in water, aqueous. And what happens when these react, there's a strong possibility, and we'll talk in a future video about how and when it might happen, but there's a strong possibility that the A and the C will just simply switch places. So now the A is with the D, and the C is with the B. Example here would be lead nitrate. Reaction with potassium iodide, the potassium and the lead switch places, and you're left with lead iodide and potassium nitrate. Now this happens to be a classic example of a precipitation reaction, and we'll see those in the video on double replacement reactions. So from a particle standpoint, here's what you got. You have a single, two elements coming together to make something whole, a big compound breaking apart to make two small pieces, a single element kicking out one of the components in a compound, or the swap, the gray and the yellow switching places. So now the yellow is with the white and the gray is with the purple. So what about these plus two? Well, the plus two, one is very, 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 very common, and one is just a specialized version of one of the big four. This acid-base neutralization is a special version of the big four, a special version of the double replacement. Notice it's still a double replacement, but here the H swaps places with the metal, and when the H swaps places with the metal, you've got this HOH, which is water, and this thing here that is the metal that was in the hydroxide with the non-metal that was with the HX. That X at HX is an acid. This is an acid. This is a base. Acid starts with H. Bases tend to end with OH. When they switch spaces, they make a salt and water. Technically, with hydrochloric acid reacting with sodium hydroxide, one of the most common acid-base reactions, you're going to have the sodium and the chlorine pair up to make salt, table salt actually, and the H and the OH makes water. The other very common type of reaction is combustion. In a combustion, you're always going to be the same thing. Hydrocarbon plus oxygen gives you carbon dioxide and water. Hydrocarbon plus oxygen is going to yield carbon dioxide and water. Anytime you're burning a hydrocarbon, any petroleum product, any gasoline, any oil, anything like that, you're going to have the same type of reaction. You're going to have the combusting of the compound is the result of it reacting with oxygen, and two of the products will always be carbon dioxide and water. If you don't have enough oxygen, sometimes you're going to be carbon monoxide and carbon dioxide, but regardless, a complete combustion, you make carbon dioxide and water from any combination of hydrocarbons. So here's some examples. You've got methane reacting with oxygen to make carbon dioxide and water. Here's balanced. There's propane, stuff in your propane grill maybe at home, reacting with oxygen to make carbon dioxide and water. And this is hexane. Hexane is a liquid solution, kind of like a light version of a gasoline, a lighter, like less heavy version of gasoline. And when C6H14 reacts with oxygen, it will make carbon dioxide and water. So they all do the same thing. Some hydrocarbon, a compound that contains carbon and hydrogen, reacting with oxygen to make carbon dioxide and to make water. Okay. So let's talk about this predicting products. So let's look at some examples. Here's a synthesis. Iron plus chlorine makes iron chloride. A decomposition, barium chloride makes barium and chlorine. Notice synthesis, I started with elements to make a compound. Decomposition, I started with compound to make the elements. Single replacement, a metal kicking out a metal from a compound. And double replacement, where the two cations switch places. If I look at this there's combustion, the version where you have in this case, this is pentane, reacting with oxygen to give you carbon dioxide and water. You'll notice they're all very, very similar. Synthesis, two elements coming together to make a compound. Decomposition, a compound making into two elements. Now I have the asterisks there because for our purposes of us predicting products, we are going to predict that it will break into its elements. But if you're looking at an overall reaction given to you, you might see something as one compound breaking into two or more smaller compounds, not necessarily always elements. A single replacement is going to be an element kicking out an element from a compound, and a double replacement, the two cations are going to switch place. So what I notice here is that every single one of these, if I know how it starts, there's my hydrocarbon plus oxygen, keep forgetting about combustion. If I look at each one of these and how they are going to start, synthesis, I have two elements. The reaction is going to take place is a synthesis. I have just one reactant, a compound. The reaction is going to happen is a decomposition. I have an element in a compound. The reaction is going to happen is a single replacement. I have two compounds. The reaction is going to happen is going to be the double replacement. And then I have a hydrocarbon plus oxygen. That's telling me the reaction is going to happen is going to be my combustion reaction. So we should be able to predict products based on what the particular starting points are. So in your packet, the first part of the packet says types of homework, types of chemical reactions and homework. You should be able to finish that with what we've done in this video. We're going to move on next to look at each one of the reactions, synthesis, decomposition, single replacement and double replacement, the big four, a little closer and see some of the subtle nuances that go along with those reactions. Until the next video, toodles.